Geometrical properties of circle. These are some rules to help you to solve the question. The first diagram shows us inscribed angles subtended by the same arc are equal, or you may say angles in the same segment are equal. The next diagram gives us angles subtended by the diameter is 90 degrees, or you may say angle in semicircle is a right angle. For the next rule, we have angle at center is equal to 2 times angle at circumference. Or, in other words, you may say angle at circumference is half of angle at center when they both subtended by the same arc. This diagram shows an angle between a tangent AB and a chord CE through the point of contact E. This angle CEA is equal to the opposite interior angle CDE. We remember this rule as the alternate segment theorem. In a cyclic quadrilateral, the opposite angles are supplementary. So we have angle A plus angle C is equal to 180 degrees. And also angle B plus angle D is equal to 180 degrees. Remember this rule as the opposite angles in cyclic quadrilateral. A radius or diameter that is perpendicular to a chord divides the chord into two equal parts. In the circle diagram, the radius OB is perpendicular to the chord PQ. Then the length of PA is equal to the length of AQ. AO is called upper thumb. The upper thumb is perpendicular and bisect the chord become two equal parts. Since triangle AOQ and triangle APO are right angle triangles, then we may use the Pythagoras theorem. AQ square plus AO square is equal to OQ square. AP square plus AO square is equal to OP square. A tangent to a circle is perpendicular to the radius drawn to the point of tangency. The next rule is tangents from an external point are equal in length. If AP and BP are tangents, then the length of AP is equal to the length of BP. The line joining an external point to the center of the circle bisect the angle between the tangent. Notice the diagram. If AP equals BP, then the angle AOP is equal to the angle BOP. The diagram shows a kite AOBP. The sum of interior angles in the kite is 360 degrees. We have angle A 90 degrees and also angle B 90 degrees because radius is perpendicular to tangent. Then we have special rule said that angle P plus angle AOB is equal to 180 degrees. Question practice. In the figure, O is the center of the circle. ABC, AED, BFD, and CFE are straight lines. Calculate angle BDC. First thing we notice from the diagram is angle EDC subtended by the diameter EC. So we have a right angle in semicircle. Angle EDC is 90 degrees. Then use the sum of interior angles in triangle ADC 180 degrees. Angle A 39 degrees plus angle D 90 degrees plus angle C equals 180 degrees. Then we get the whole angle C is 51 degrees. Then we calculate angle BCE from 51 degrees minus 28 degrees equals 23 degrees. You see there is an equal angle angle BDE equals to angle BCE because they are angles in the same segment subtended by the same arc EB, and the size is 23 degrees. And because of that, we can find angle BDC is 90 degrees minus 23 degrees equals 67 degrees. In the diagram, O1 and O2 are the centers of the circles. PO2 and QO2 are tangents to the bigger circle at points P and Q respectively. And angle ATB equals 36 degrees. Find angle ASB and angle PO1Q. When you have a cyclic quadrilateral ASBT, the opposite angles add up to 180 degrees. Then angle S plus angle T is equal to 180 degrees. Angle S plus 36 degrees equals to 180 degrees. And we get angle ASB is 144 degrees. Then we see the angle O2 is angle at center, which is 2 times angle at circumference. Angle O2 equals 72 degrees. Angle PO1Q is angle at center, and angle PO2Q is external angle. Remember our last rules about the kite? Angle O2 plus angle O1, the sum is 180 degrees. So we get angle PO1Q equals 180 degrees minus 72 degrees equals 108 degrees. In the diagram, A, B, C, D, and E are the points on the circumference of the circle with center O. AE and BD are parallel. Angle EBD is equal to 44 degrees, and angle BDC is equal to 25 degrees. Question A. Find angle BED and angle CAE. Question B. Show that AD is the diameter of the circle. You have angle BDE subtended by the diameter BE. So, this is a right angle in semicircle. Angle BDE is 90 degrees. Use the sum of interior angles in the triangle. Angle B plus angle D plus angle E equals 180 degrees. 44 degrees plus 90 degrees plus angle E equals 180 degrees. Then, angle BED is 46 degrees. The whole angle D is EDC equals 90 degrees plus 25 degrees equals 115 degrees. Then we also have a cyclic quadrilateral ACDE. The opposite angles in cyclic quadrilateral add up to 180 degrees. So angle A plus angle D equals 180 degrees. Angle A plus 115 degrees equals 180 degrees. Then angle CAE is equal to 65 degrees. We have parallel lines AE and BD. So you have alternate interior angles the same. 44 degrees at B and also 44 degrees at E. Then we can find the whole angle E, which is 44 degrees plus 46 degrees. Angle AED equals 90 degrees. This is the proof that AD is diameter. In the diagram, PA and PB are tangents to the circle with center O. PCO is a straight line where C is a point on the circle. Question A. Find the value of M, where PC equals M centimeter. Question B. Find angle BPA. The radius BO is perpendicular to tangent PB. Then we have angle PBO is 90 degrees. You may use Pythagoras theorem for the right angle triangle PBO. PB square plus OB square equals to PO square. 12 square plus 5 square equals M plus 5 square. 169 equals M plus 5 square. And 13 square equals M plus 5 square. Or M plus 5 equals 13. Then the value of M is equal to 8. In triangle PBO, we may use trigonometrical ratio tan P1 equals 5/12. And the angle P1 is 22.6 degrees. The whole angle P, which is angle APB, equals 2 times 22.6 degrees equals 45.2 degrees. In the figure below, TA is a tangent to the circle ABCD with center O. Angle TAD equals 48 degrees and angle BOD equals 116 degrees. Giving reasons, calculate angle ACD, angle ABO, angle ADO, and angle ACB. When you have the angle formed between the chord and tangent to a circle, it will be the same with the opposite interior angles. So angle A 48 degrees will be the same with angle C 48 degrees. This rule is called as the alternate segment theorem. We will have angle at circumference equals half times angle at center. So angle A is equals to half times 116 degrees. We have angle A equals 58 degrees. The other alternate segment theorem we can use for angle A on the left is equal to the opposite interior angle at C. How to get angle A on the left? Using a straight angle 180 degrees minus 48 degrees minus 58 degrees. Then we have angle A on the left is 74 degrees. This is equal to angle C 74 degrees using the alternate segment theorem. The other 74 degrees again, the same with angle C, is angle D. Why they are the same? Because angle C 74 degrees and angle D 74 degrees, they are angles in the same segment. Both of them subtended by the arc AB. Another angles in the same segment is angle C 48 degrees equals to angle B 48 degrees. Both of them subtended by the same arc AD. Then we can calculate the isosceles triangle OBD. This triangle have the same angle. Angle B is equal to angle D. To get the size of angle B and angle D inside the triangle OBD, we can calculate from half times 180 degrees minus 160 degrees equals 32 degrees. Now we can calculate the size of angle ABO from 48 degrees minus 32 degrees equals 16 degrees. And we can calculate the size of angle ADO from 74 degrees minus 32 degrees equals 42 degrees. Finally, we already answered all the questions. Please subscribe if you like this video.